Dr. Felix, can I start my video? I mean,
yes, yes, we are streamed online now. It is live on YouTube, so you may start the program.
I'm starting then. Good morning, dear participants. I am Shyampur De, Assistant Professor and Head, Department of Botany of Shyampur, Siddheshwari, Mahavidyalaya, and I would like to invite you all in our one-day national webinar entitled Plant Life in Antarctica, which is jointly organized by Department of Botany and IQAC of Shyampur Siddheshwari Mahavidyalaya in association with Young Academy of India. Now, talking about this plant life in Antarctica, we all know that 98% of Antarctica is covered with snow, and it is considered as one of the driest continents on Earth, as most of the precipitation occurs in form of snow. And to survive in this extreme climatic condition, plants need to be able to withstand several stress conditions such as repeated freezing and thawing and limited source of nutrients and fresh water. Today we have amongst us Dr. Felix Bast, who is an eminent researcher and currently working as an associate professor and head Department of Botany of Central University of Punjab. He was a part of 6 months long expedition to Antarctica, which was the 36th expedition led by India. He and his team discovered a new species of moss from there, and we are extremely happy that he is here with us to deliver a talk on his discovery and share his knowledge with us. Now, before that, I would like to invite Rajoshi Mukherjee, our IQAC coordinator, to deliver his welcome address. Over to you, Rajoshida.
Thank you very, very much, Shatarupa. Am I audible?
Yes, you are audible.
Okay, so welcome to all of you and welcome to the eminent speaker, Dr. Felix Bast. We are hopeful that it will be an enriching session which lies ahead of us. Shyampur Siddheshwari Mahavidyalaya has been consistently trying during this pandemic to keep this flow of academic exchange alive and active. And we have been doing this consistently, and the Department of Botany has come up with 2 webinars earlier, and this is the 3rd effort. I'm sure that this is going to be an exciting session where the participants are going to be enriched by the experience and the research of Dr. Felix Bast, the eminent scientist and the head of the Department of Botany, Central University of Punjab. I wish this webinar a grand success. Thank you once again.
Thank you, Rajoshida. Now I will request my colleague, Shati Sheth, for officially for introducing our speaker.
Thank you, Shatrupadi. Dr. Felix Bast is an author, public educator, and associate professor based at Central University of Punjab, Ministry of Education, Government of India, Punjab, India, where he is heading Department of Botany. He received his BSc with University first rank and gold medal in the year 2000. He received his MSc from University of Madras and worked at IIT Bombay as CSIR Junior Research Fellow. In 2005, he was selected under prestigious Mon Bukakagucho Japanese Government International Doctoral Fellowship and earned his PhD in molecular phylogenetics from MEXT, Japan in 2010. Dr. Felix received a number of international recognitions and underwent training from a number of institutions worldwide. In 2007, he underwent 2 months research and training at Friday Harbor Laboratories, University of Washington, with fellowship from National Science Foundation, USA. In 2009 and 2013, he underwent training at Natural History Museum, London, and Marine Biological Association, Plymouth, 2013, UK, supported by international fellowship from British Psychological Society. He has been serving the government of India since 2010, when he took an appointment at the Central University of Punjab. Dr. Felix Burst served as an invited in-residence intern with the President of India as an inspired teacher for 1 week at Rashtrapati Bhavan, New Delhi in 2015. Amongst many discoveries that his team at Central University of Punjab has made include a species of moss from Antarctica, featured in BBC News. The first plant species discovery in 40 years of Indian Antarctic mission, and 5 new species of marine microalgae from different parts of India. Dr. Bast is a known science communicator in India through his writing, outreach talks, and YouTube videos for fostering critical thinking and scientific skepticism. His talk has been featured in numerous media, including All India Radio, Rajya Sabha TV, and TEDx. Dr. Bast served as an elected National Core Committee member representing biology and medicine at Indian National Young Academy of Sciences, 2020. Subsequently, he founded India's first Young Academy open to all fields of knowledge, Young Academy of India, and initiated its integral program. He is also a member of National COVID-19 Task Force by INSA and Indian Scientist Response COVID-19. Dr. Bast is also involved with SWAYAM, a flagship online education program of Ministry of Education, Government of India, as a course coordinator. In addition, he is an avid cyclist, a runner, a frequent blood donor, and an advocate of zero waste and low carbon footprint lifestyle. We are extremely proud and happy to have him with us. Thank you so much, sir. Now, may I please request to Dr. Bast to start his valuable speech. Thank you.
Yeah, thanks, Sati Seth and others in here, Dr. Satrupa De, for inviting me here. Could you please stop sharing so I can, the audience can see me speaking? Dr. Satrupa, could you please stop sharing the screen?
Yes, I'm stopped.
Yeah. So thanks for inviting me here. I'm really happy to be with you all. I can see that a lot of people have joined the YouTube. And so before I begin my talk, this is going to be a very brief talk, but I'm more interested to hear from you, the audience, as well as the people who have joined here in the Zoom. So if you have any questions about the kind of work that I do, about taxonomy, or about Antarctica in general, or Indian Antarctic mission, you're free to ask the questions in the YouTube chat box. Okay, so I would like to spend some time with you all on interaction, not merely sharing my story. I would like to know what you think about this story and the repercussions that I'm going to discuss today. So first, let me share my screen and let me go with the talk. All right. So today's talk is titled Brian Bharati and Say Insights into Polar Biology. So as you know, Brian Bharati and Say, Brian is a genus of moss, and I can see that this is organized by Department of Botany at this college. Yes, so thanks for having me here, and I'm really happy to be with you all for this particular program. So what this discovery is all about, some of you might have seen this discovery in the BBC News. It has come on recently in the BBC. So what is that all about, this this particular discovery? So as you know, this is from Antarctica. So the continent Antarctica is a very, very special continent. It's almost 99% ice. And more than that, it traps majority of the most of the fresh water resources on planet Earth, And we know that the continent is changing dramatically because of the climate change, right? Because of the global warming, ice is melting, and also many other repercussions, including what I'm going to discuss today about greenifying of the continent. The continent is getting greenified because it's getting warmer and warmer, and some temperate species can now come and occupy and colonize in this continent. It's very interesting, isn't it? So the continent Antarctica is a very special because this is the only continent on the planet Earth without any religion. And today is a very important day by the UN, United Nations, International Day for observance against the violence done by the religion and belief. We know that what is actually happening around the world. So this continent Antarctica has no religion and no pseudoscience, only science. The continent is devoted only for scientists and for the scientific curiosity driven investigations. Our team, of course, I was part of the Indian Antarctic mission. The team consists of doctors, nurses, engineers, electricians. We also have supporting staff from BSF Jawans, and of course, our team didn't have any pseudoscience, no alternative medicine allowed in Antarctica. Okay. And yes, so this is very interesting aspect. No religion, no pseudoscience. Okay. And this Antarctica has got some ice-free regions. I told you most of the Antarctica is, it's covered by two massive ice sheet, East Antarctic ice sheet and West Antarctic ice sheet, 99%. But still it has got some ice-free regions called oases. So two of the most important ice-free oases are Shyampur oasis and Larsemann Hills region, So this Shyampur oasis is home for India's one of the oldest, the Antarctic station called Maitri. Of course, we had earlier than Maitri, we had Dakshin Gangotri near to that area, somewhere here, but somehow that station got disappeared in the ice because of the temperature, the flaws in the construction, the civil engineering mistakes. So we have one station right here, it's called Maitri, and we also have another station somewhere here called Bharati. And this is in Larsemann Hills. So while wandering around the regions near the Bharati station in the Larsemann Hills, specifically Fisher Island and McLeod Island, I stumbled upon a turf-like algae. So this is the algae here, the moss, the plant, right? So the moss is, of course, it's very soft, and it's turf-like. And I thought, like, how the moss can live in Antarctica. And of course, it's not that the first time, the discovery is not the first moss species in Antarctica. There are well over 100 species of moss. But still, it fascinated me how the moss can live in Antarctica, I was always curious. So the curiosity is all about, tell me how. So tell me how the moss can live there. Right? That childlike curiosity is really important. A child might ask questions like how a lizard can walk on the walls of the house, So yes, or why we yawn, what is the reason for yawning? So that kind of questions are usually asked by the children. And the moment the children pass through our formal education, the questions would take a different dimension, like how to prevent cancer, how to make more money. All these things will be centered on one species on planet Earth, that is Homo sapiens. So never lose the childlike curiosity. That actually leads to much of the dividends in form of discovery. So that's really, really important to have that curiosity. So by the way, that how the lizards can walk on the wall of the house or the ceilings. So that questions have led to discovery of some very interesting force called van der Waals force. It's a weak electrostatic interactive force. And that is the reason for microfiber cloth. If you're using microfiber cloth for cleaning your home, like this kind of cloth. So this is also worked by the Van der Waals force. So it's very interesting to see, to be open for new ideas and to be open for curiosity. And right here in my channel, I have a program called Curiosity, which is a monthly science show. So tune in, right? So every month I release one episode. Of course, it's part of my activities as part of the Young Academy of India, right? So this is how the moss looks like. And one interesting facet of ice-free oasis in Antarctica is that it has only rocks. There is no soil there. So how could the moss live in? Of course it needs nitrogen and phosphorus, but without soil, how can it live? So studies have revealed that mosses like this have got a different isotope ratio of nitrogen. So if you look at the nitrogen, so nitrogen have got two isotopes, N15 and N14. So the lighter isotope, the N14, usually we excrete out, the animals excrete out. So we keep on accumulating the higher, heavier isotope, that is N15. And the ratio of N15 to N14 gets higher and higher as trophic level increases, because of biomagnification, you see. So like cow and all, they are primary trophic level, right? So secondary trophic level, of course, a primary producer and then primary consumer, right? So cow are, of course, these are herbivores. So cow might be having a very low N15. At the same time, birds, or penguins have got very high N15, Usually plants have got extremely low N15. N14 is much higher. But very interestingly, the mosses have found that it has got more N15. So that means that moss is getting the nitrogen directly from animal source. So of course, we have also found that the moss is living in the areas where penguin rockeries are in. So wherever you see the Adelie penguins and emperor penguin rockeries are nothing but breeding grounds of penguins. You can see this kind of algal growth. So that has led to a natural conclusion, a probability that they are getting the nitrogen from penguin guano, which is an excellent fertilizer. Another interesting question that we had is that, how this plant can survive in Antarctica. Antarctica is very special that 6 months is continuous summer there, while after that, next 6 months is continuous winter. So that the 6-month summer is fully light. Well, of course, it's good for photosynthetic organisms. But what will happen when the Antarctica gets into the winter months? So right now it is winter. So only in September equinox, it will get the first sunrise. So basically from September to March, it's complete light, while March to September is complete darkness, right in the South Pole. Of course, it varies when you get out of the South Pole, rest of the Antarctica. But yes, so how it can survive, and more than that, how can this the moss live during the winter months where the snowfall is also extreme? So it would be inside the snow, so almost 10 meters of snow. So it's the high pressure also. So probability is high that the algae goes into a dormant state, and it actually it's something like spore kind of form, the dried up state, and it absorbs the water. And then with the September equinox, and then when the snow starts melting, and with the water it starts germinating again and again, so that way the cycle continues. So that is a probability. So it's very interesting. So how did we actually describe it as a new species? So of course we used a polyphasic method. So we combined the morphology. So in taxonomy, there is a concept called synapomorphy. Those are nothing but distinct feature. What are the distinct feature of this particular moss? So of course we could able to find out so many distinct feature. For example, unbranched the thalli that the plant habit, while the rhizoids were branched, and ovate lanceolate leaves with long acuminate apex and decurrent reflexed and cerulate margins and Perker and Costa. So many of the features we could see it. So it's really important that you have to actually support your finding with morphologically distinct features. So that's really, really important. And this is our 6th discovery. All the 5 were the seaweeds in all around India. So the seaweeds include Ulva Paschima. That is the first seaweed which we discovered in the western coast of India, and then Cladophora goensis, then Ulva uniseriata, and Hypnea indica, Hypnea bullata, and this one, the final one is Bryum paratiensis. We made another discovery, so I'm going to share that as well here. So as you know, the pattern that I follow for naming a new species is either based on the region where it is found, for example, this Bryum paratiense, near the Paradis station, or based on the botanical features of the thallus or the plant shape. So like, for example, Ulva uniseriata. So that means it's a uniseriate filament, or Hypnea bullata. So that is blisters on the surface, surface of the thalli. So I'm completely against naming after human beings, because there is an anthropocentrism. Why should we name this after human beings? And you will never know what will happen, after the naming, especially if the human being is living. So what if the person gets, found guilty in a serious, heinous crime, like, pedophilia, for example. So it's not fair to name after human beings, especially living human beings. I'm completely against that concept. So that is the reason that I will never name any of the discovery after the human beings. So of course, we validated our discovery by 2nd degree of evidence, and this is from the molecular evidence from from the DNA sequencing. So this is based on the internal transcribed space or sequence, the DNA sequence. So we found that the new species did not cluster in any of the existing Bryum species. So that is that in addition, that actually supports our discovery. So it is basically Bryum pseudotrichestrum is the nearest match, and the difference is enormous. And also we had a large number of synapomorphic characters. So that is what. Then we have to decide on the species name, and of course, Bryum paratiensis seems to be the best fit. The main reason is this is named after Paradis station, and of course, Parati is a goddess of learning. So by naming this as Bryum paratiensis, I emphasize on the importance of learning, especially lifelong learning. Learning should never stop. The Einstein famously said, the day you stop learning, you start dying. So that's the very importance of the lifelong learning. So that is one of the another reason why we named it as Parati. And also, of course, Parati is also related to Bharat, the station, and this is part of the Indian Antarctic mission. And I'm really privileged to be part of that Antarctic mission too, right? So these 3 are the reasons for naming it as Bryum paratiense, right? And now the next part of my talk is behind the scenes. How did I actually made it to Antarctica? You might wonder. How did I become part of Indian Antarctic mission? And if you are interested, how can you apply it to be part of Indian Antarctic mission? You can do it. Nothing harm. I mean, anybody can go to Antarctica, provided that you have some interesting idea. So I just want to make sure that I'm audible and YouTube is working. So could you please, organizer, could you please confirm all is well? Sorry, I don't hear you. Could you please confirm that all is well? I'm audible. There is a lot of rain going on. Perfect. All right, so let me go to the second part of the talk. This is the behind the scenes. So the Antarctica, I told you, Antarctica is a very interesting place. So I've been till now 23 countries, and nowhere like Antarctica. Antarctica is a place, it's a very special, because even if you have like crores of rupees in the bank balance, you cannot go to continental Antarctica by paying money because tourism is not allowed. And you might know that usually to go to other countries, you need to have a passport, right? The color of the Indian passport is blue, right? The blue or dark blue or black. That is the personal passport. You cannot go there. To go to Antarctica, you need to be part of national mission. You need a special passport called official passport of Government of India or diplomatic passport of Government of India. So it's prestigious to be a part of the Indian Antarctic mission, And also, this is the only continent that none of the holy books of any of the religions mentioned, because the continent completely remained unknown to a human being till 18th century. I would say 19th century, 19 to 1820s. That is the 19th century. But even there are mention of stars and moon in most of the holy books, because our ancestors could able to see the moon, rising and setting, right? The stars, the sun, everything is there, but Antarctica is completely missing. The Uranus, the planet Uranus was discovered earlier than Antarctica. It was discovered in 1781, such a distant planet Uranus, but it was in 1820 that Antarctica got discovered, right? So yes, so to go to Antarctica, of course, you need to apply for the national mission. Why you want to be part of it? There are two ways. One is that to be as a scientist. If you're into basic sciences, you can do any kind of work. Like in my case, I made a proposal to work on the plants, the floristic diversity of Antarctica. And if you're a physics student, you can write on upper atmospheric physics or aurora or australis, the southern lights. Or astrology, if you're interested to work on the planets and moon and stars and constellations and galaxies, you can do it. Or if you're from chemistry, you can work on halogens and anything. I mean, carbon concentration in Antarctica. Also on glaciologist, also part of a geologist. For example, the rock. Mathematical modeling, or even human medicine. Like what changes that human body undergoes when you go to Antarctica. So after you make a proposal, you submit to the Ministry of Earth Sciences in Government of India in New Delhi. Then they will call you to defend your proposal. And then after that, the next step is a complete body checkup. So it's not a simple blood test, friends. It takes almost a week-long test in AIMS, All India Institute of Medical Sciences in New Delhi. And especially they will look if you're a smoker or have you been drinking, because they will do a lot of tests, including treadmill stress test and even liver, scan and the cotinine test that detects nicotine in the urine. The reason is that Antarctica being such a isolated place, there is no hospitals, and in case of a mild heart attack, chances are high that you might lose your life. Of course, we had medical doctors and nurses in our team, but still without equipments and without any procedures, chances are very high that it's extremely risky. So that is the reason why, the health is really important, the fitness. So if you want to go to Antarctica, especially the youngsters watching this video, my first advice to you is, if you are drinking, quit drinking. If you are not drinking, never start drinking, and never smoke. These two very interesting, very important habits is the key to be a fit life. In order to pass the medical tests, right? And after that, there is almost a month-long acclimatization training in Oli and Mana Pass in Uttarakhand in Himalayas by Indo-Tibetan Border Police. So it is more like surviving in such an extreme habitat, how to survive, how to walk on the snow, all those things, Then I told you, official passport of the Government of India, and the team consists of around 100 people. And of course, besides the scientists, we also had got supporting staff. I told you, doctors, nurses, engineers, diesel mechanic. Diesel mechanic is really important because without diesel engines, none of us can live in Antarctica. The stations are heated with the diesel. It's basically jet propulsion fuel, number 8. because even diesels can freeze in Antarctica. Antarctica is a extreme habitat, you know. So yeah, that is what. Then we went in a ship. It's basically an icebreaker ship. Normal ships cannot go to Antarctica. You know, you need a very, very capable ship. Yeah, very, very a strong ship that can take you to Antarctica. Unfortunately, India has not a single icebreaker ship, and that is the reason we got the ship. We rented the ship from Russia. The ship is called Ivan Papanin at a very exorbitant rate, 1.5 crore, I guess, per day. And you have to hire it for almost 6 months in one go, you know, because it takes a really long time to reach in Antarctica, right? So this voyage turned out to be a voyage of self-discovery. I have authored one book called, The Voyage to Antarctica. You can have a look on that book. Yeah, you can just Google it and you can buy the book. I mentioned the entire story from the start to the finish. What I'm sharing today is it's a kind of subset of that book. And you see, there is a very important risk factor also. You know, it's not like a normal tour going to Antarctica, you know. So it's highly risky, and many scientists die in Antarctica, and many supporting staff as well, many students too. The reason is that it's risky. Even to walk in Antarctica is risky because there are crevasses. On the top, it looks like a snow, but the moment you land on it, it can break and it will take you to the deep crevasse and instant death. And that is the reason most of the professors and scientists are delegating this task to their PhD student. Against that, I want to go there myself. Of course, it's risky, but yeah, it can pay. That is the reason why I actually could able to make this discovery. You see, my own trained curiosity. I was curious there to see that what actually how the moss can live in. So that is the reason why the story became so popular, and I could able to make this the discovery. And it's just because never lose your curiosity, you know, never lose your childlike curiosity. That's really, really important. And even the journey itself is risky. And the ship used to roll and pitch extensively during when we cross the southern poles latitudes, like roaring 40s, furious 50s, and screaming 60s. These are 40 degrees south, 50 degrees south, and 60 degrees south. These are poles latitudes, you know, westerly and easterly winds that completely roll the ship, you know. So it's really risky. And finally, we reached the Maitri station. By the way, in Antarctica, where all the longitudes converge, if you travel a little bit, the time changes. That's very interesting, you know. And right at the pole, the South Pole, you can step from yesterday to today to tomorrow. You might wonder how come. Yes, with one step, you know, you can travel from yesterday to today to tomorrow, because all longitudes converge there. You can do a circumpolar navigation of the earth just by few steps, 3 steps, you know, right in the pole. So we used to follow London time in Maitri station, the Greenwich Mean Time. And the station is a very old station, commissioned in 1988. It's the second station after Dakshin Gangotre, I told you. And yes, so the station is there are living modules in that station. And yes, so there is that is what we call it as Maitri station. Our latest station is called Bharati, which is commissioned in 2012, and the whole station is made in Germany and disassembled, and then it took in the ship in the same ship, the Ivan Papan, and then they reassemble it. It's like a giant jigsaw puzzle, you know, or the Lego bricks, you know. Very interesting, isn't it? And the whole station is made up of shipping containers. So some of you might have never seen shipping containers. You might have seen the Malgadi, isn't it? The goods train. So Maersk and all those the bogies in the goods container. Goods train is nothing but containers. So those containers are the one which the station is made up of. And the station has got several laboratory functional labs in it. So it's very interesting, and it also has got Wi-Fi. Very interesting station, Bharati, and this is the reason why I named it as Bharatiense, because I got the mosque in the vicinity of the station, not really in the vicinity, around 20 kilometers apart, but still I was based in this station when the finding happened. Now, coming to the next part of the talk is the impact. So how this discovery is really interesting, and what are the potential impacts of it? First of all, this is the first discovery in the last 40 years of the Indian Antarctic mission, the first plant species discovery. So that is why it's very special, and international media reported quite extensively, including BBC News, getting in the front page of the BBC. Indeed, it's a big thing, And of course, many of the media channels around the world, UK's Independent, Germany, Lithuania, Turkey, France, Hungary, all those things have covered the story extensively. One of the major impact of the story is that this is yet another proof of a world over there is an ongoing phenomenon of greenifying Antarctica. The continent is greenifying. So this is a paper from one of my friend from Cambridge University, and Matt Dewey. So this is basically it's a remote sensing based proof that Antarctic, this is basically Antarctic Peninsula, or rather not really the Antarctic continent. Antarctic Peninsula is a finger shaped projection towards the Drake Passage and South America, the Chile and Argentina, the Patagonia section of the Argentina. So this section is completely greenifying now. These are the pictures from the satellite, and ours is a ground validation of that finding. The moss are getting more and more wider, the dispersal. So is it because of the dispersal or vicariance? We have no clue. So by the way, what is this term, vicariance and dispersal? So vicariance means speciation, that is the formation of new species because of the geographical barrier. Or dispersal. Dispersal means it is dispersed from elsewhere. So it might be the fact that the species, the Bharatiense, is already there in Antarctica millions of years back. And because the Antarctica is now melting, so the spores are started germinating. We don't know. Or is it because of the introduction from elsewhere? Because, like, for example, scientists like us, when we go in as part of the national mission, the shoes might carry some spore and gets introduced in Antarctica from elsewhere. So we have no idea which is the truth. So before going to Antarctica, right in 2016, I happened to go to Norway. Norway is a Northern European country, and I went to Tromsø, which is right inside the Arctic Circle. A place where I went is called Lofoten Island. So I took a ferry in Lofoten Island, and while going in the ferry, I was looking outside the glass door, and I was so surprised to see mosquitoes there. I asked the other ferrymen, the co-passengers, and I asked, like, is it strange to spot a mosquito in Lofoten? Because it's in the Arctic Circle. It's supposed to be a very cold place, and mosquitoes cannot live in such a cold place. And they said that even for them, it's strange. For the last decade, the mosquitoes started coming, but before 10 years, there were no mosquitoes in Tromsø or rest of Norway. But now it started coming. So same phenomenon, greenifying and species dispersal is being affected because of the climate change. And we have no idea what is actually underneath the ice sheet. If you have read Dan Brown's Deception Point, similar theme, was featured in this Deception Point too. So there might be pathogens underneath the ice sheet, like novel coronavirus. Who knows? The next coronavirus might be there. So all we can do is to slow down the melting by taking a sustainable lifestyle. I've been advocating the importance of sustainable development through this channel for quite some time now. So you can also adopt a lifestyle which is as close to nature as possible. So I'm really happy that this is a talk in West Bengal. And one of the places I went, I will never forget, is Gosaba village. I'm sure many of you have been. It's near in the Sundarban. And Gosaba village is one of the cleanest, in the villages in India where I went, and the village also had virtually nothing, no electricity, and still they had a hut with the thatched roof and solar panels and fantastic, no plastic, nothing, and superb. I'm really impressed with the kind of lifestyle that the Gosaba people are they're doing. So we need to, adopt that kind of lifestyle to prevent the next coronavirus and to prevent, next pandemic, and to prevent the global warming and melting of the Antarctic continent. This is a report last few weeks back by Ohio University team in our own Himalayas. They found 15,000 years old viruses discovered in the Tibetan glacier ice. So because of the global warming, even Tibetan glaciers are melting, and because it's melting, so there are viruses lurking underneath these glaciers that is now being gone out. I mean, they are actually being discovered by the scientists. So of course these might not be pathogenic, but we will never know are these pathogenic or not, you see. So scientists have confirmed that 1.5 degrees Celsius is happening every 5 years. So in the next 5 years, 1.5 degree rise will happen in the global mean temperature, which is a very, very high, so it is extreme. I mean, IPCC recently, they came out with very alarming climate change predictions, so that is why the sustainability is extremely important. Check out the Curiosity Science Show. I keep on featuring the studies on these slides. The geologists around the world, especially American Geological Society, the consensus is that 50 years, within next 50 years is going to be next major geologic event of the planet. And guess what? This event is going to be complete breakup of Antarctica. So because of the melting, you see, accelerated melting. And what are the ramifications? Of course, the sea level will increase. Low-lying areas like Sundarbans will be completely submerged. Even Bombay, the city, even it has got ramifications on the Earth's rotation. It slows down the Earth's rotation. So the days are going to be longer and longer. So it's going to be terrific, friends. We really need to see how we can stop it from happening. And other impact is that any studies on extremophiles, especially the physiology, can give us the clue on survival strategies and what to look for in extraterrestrial life, that is the astrobiology or exobiology or cosmobiology. Also, it gives the clues on the origin of life right here on the planet Earth. How did the life originated on the planet Earth? So the Antarctica is a very interesting place that the temperature is -79, up to -79 is a ground validated proof we have. It's just like the moon Enceladus in our solar system, and also the overall atmosphere is quite similar to extraterrestrial atmosphere. For example, it's the extreme cold I told you, plus it is highly dry place, the driest continent on the planet Earth. What is underneath this continent? If you drill a hole, you will see that is 3 kilometers is the average thickness of the ice sheet. And underneath the ice, there are subglacial lakes. There are lakes, and the lakes are, it is not ice, it is liquid water, because it is under, it's touching the rock, so the rock is always hot at that depth, you see, because of the geothermal effect, isn't it? And between these subglacial lakes, there are secret conduits, the so-called secret rivers of Antarctica. And when you hear the word river, so river is usually flowing down, isn't it? But in Antarctica, there are rivers that flows up. What? Flowing up? Defying the gravity? Yes. Because of the extreme pressure, the hydrostatic pressure, and it functions like a syringe, so it can actually flow up hills. Very interesting. There are volcanoes. The UV light intensity is also extremely high because of ozone hole, pollution in ozone hole, the halogens, right? Chlorofluorocarbons. So In our sense, Antarctica is exactly like a moon or extraterrestrial habitat. For example, Mars. Mars is one of probability of life is very high in Mars. So that is what the Mars missions like Curiosity rover. All these things are really important for finding out. So we also have ISRO also have got a plan to go to Mars, right? So average surface temperature is minus 63 degree. The average, of course, Antarctica temperature can go still lesser than that temperature, you see, and also up to 27 degrees in near the equator during the noon time. So of course in Antarctica 27 degrees you will never come across. So Mars is kind of warmer than Antarctica, you see. So there is a very high chance for finding the life on Mars. Enceladus is it is a moon of Saturn, the ring planet, right? Sixth largest moon, and the average surface temperature is very cold, minus 201 degrees. And the most reflective because of the ice. It's just like Antarctica, it's a white continent, the white moon. The Enceladus, like the Antarctica, is a white continent, just like the official passport of government of India, right? That is also white. You see a lot of similarities, isn't it? So Cassini and Huygens probe, these probes have found continuous icy gush near the poles of Enceladus. So that is a very interesting hope for finding the life in the Enceladus. There is a very high probability that the liquid water might be there. Titan is another very interesting moon, which is quite similar to Antarctica, friends. The largest moon of Saturn, the second largest in the solar system, and the temperature is minus 179 degrees Celsius, very, very cold. But the interesting fact is that this is the only moon with a thick atmosphere. Moon, by the way, is natural satellite. That is what we call it as moon. Yes, so this has got thick atmosphere, and guess what? The atmosphere of Titan is also mostly nitrogen, just like Earth's atmosphere. And it has got liquid water too. So liquid water has been revealed by Cassini and Huygens probes. Saturn probe, right? Huygens by the European Space Agency and Cassini by NASA have revealed it. Yet another moon which is quite similar to Antarctica is Ganymede. Ganymede is the largest moon of Jupiter, the largest planet, you see. And Ganymede is the largest moon in the solar system. It is a huge, really big planet. And it's the only moon with a magnetic field. It's very interesting. It has its own magnetic field. And because of magnetic field, it has got aurora, like aurora borealis and aurora australis. Like in the case of Earth, Southern and Northern Lights. And yes, so that is quite similar to Antarctica, you see. And Hubble and Juno space probes have revealed there is underground seawater ocean. Very interesting, again, quite similar to Antarctic ice shelves. Underneath the ice shelf, the projecting part of the continent, of course, is the ocean, you see. And yeah, so it also has got atmosphere, very thin though, and it has got oxygen in the atmosphere, in its atmosphere. Very interesting. Oxygen. Finding oxygen in the atmosphere is extremely rare, you see. And the surface temperature is around minus 180 degree, very, very cold, quite similar to Antarctica, And Europa is yet another, finally, the moon of Jupiter. This is the smallest moon, Europa. And the water plume in the South Pole has been detected by the Galileo mission. That is why we are very hopeful of finding light. We have excellent evidence that the water exists. So liquid water, you really need the liquid water for life, right? Life, as in the life of the planet Earth. To have that kind of life, you need to have liquid water, not liquid methane will not suffice. So Europa is a very exciting place for extraterrestrial life, the exobiological surveys. So yes, minus 160 degrees Celsius is the temperature near the equator. So that is the reason that Antarctica is an exciting avenue for astrobiological research. In addition, I told you in winter, so winter is, from March to September is complete winter. March is the day when Antarctica slides into winter by the first and only sunset. And if you look at the sunset, this is during the equinox day, March equinox, that is on 21st March, you will see two sun on left and right because of the optical illusion, yes, so it is because of the diamond dust, and refraction, double refraction through the diamond dust. These are nothing but snowflakes on, not really snow, but ice flakes on the atmosphere. So after the sunset, I told you from March to September, it's pitch dark in Antarctica, and that's a great time for astronomical observations. This is my own picture of our aurora, our Milky Way, our own galaxy, the spiral galaxy, isn't it? Yes, so aurora australis also, you can see it. These are nothing but mesmerizing southern lights. Look at that. This is the container ship I told you. I was living in this container. I was living in this, this is a living module. This is a camping spot. So these two are the pics I took. So you can see that, the color. So the color is nothing but, the color is because when the charged particle, from the sun strike the atoms in the Earth's atmosphere, so it caused the electrons of this, the molecule that is basically nitrogen, right? Mostly nitrogen, oxygen, and carbon dioxide. So electrons, exile electron goes to the higher orbital, and when it comes back, the difference in the energy state is released as photons. So that is the reason for this interesting color, So you can see that by looking at the color. For example, this one is, the purple color. We know that the purple is because of the nitrogen, because that energy corresponding to the purple is exactly how the shell electron state in the nitrogen is. And by looking here, this is kind of a yellow-green color is oxygen. So this is exactly the same way the astronomers use astrophysical spectroscopy to see the kind of, like oxygen in Titan and Europa and all, right? So planets and stars far, far away, we can predict what kind of atmosphere it has got by spectroscopy. And of course, Antarctica is home of some of the largest telescopes in the world, including South Pole Telescope, which is operational year-round because it is working on microwave radiations. So, yes, so this particular the telescope looks after cosmic background radiation, the afterglow of Big Bang. So that is why we know that we have proof that the universe is expanding. The Hubble constant you might have heard of in the physics, right? So all these proofs come from the South Pole Telescope, and also this is the South Pole Telescope was instrumental to produce the first black hole picture that has released 2 years ago. So telescopes in Antarctica have revealed almost 4,000 confirmed exoplanets till date. Exoplanet means like like Earth and other planets. The 8th planet, the 9th one is no more a planet, the Pluto. The size of Pluto is even lesser than moon, our own moon, so it is not a planet, right? So 8 planets we have, and like these 8 solar system planets, there are 4,000 exoplanets till date discovered by astronomers. So like 2 of the most important exoplanets that exobiologists or astrobiologists are looking after is called Kepler 1649c and Proxima Centauri b, and also Glacier 106 1d and 1c. So these 4 planets are the current favorites of the astrobiologists. So astrobiology is really, really interesting, and for that we really need a powerful telescope. Unfortunately, India has not a single telescope. I have actually highlighted the importance of this in the book Voyage to Antarctica. We really need to have telescopes in Indian Antarctic stations. And astronomy had been our original fort in India. If you look back, ancient India, Aryabhatta, for example, right, or Bhaskara, all these are champions of curiosity-driven basic sciences, not merely satellites and rocket, but basic science, astronomy. So astronomy, we really need to highlight through these kind of telescopes, the only way out. So yes, so that is why that the bias I would like to emphasize, the bias in the research is basic versus applied. So unfortunately, the government is spending lots of money on applied research like satellite and rockets, but not on the basic research. Of course, astrobiology, exobiology, astronomy, all these are part of the basic sciences, you know, like what Aryabhatta has been doing centuries ago. So we really need to highlight it. And additionally, this is my own picture from a helicopter. Usually we travel in Antarctica by helicopters, you know, so reconnaissance mission. And in the helicopter, you can easily spot penguin. These are nothing but march of emperor penguins. It's very easy to spot penguins in Antarctica. Do you know why? Because the penguins are black and Antarctica is white in color, right? The continent is white, it's a white continent. So anything black you can easily spot. And that is the same reason Antarctica is a heaven for meteorite rock hunters. Geologists and astrobiologists who are looking after meteorites, Antarctica is a heaven. Almost 99% of the meteorite rocks that we have on the planet comes from Antarctica. It's not that other places where we don't get the meteorites. Of course, there are meteorites, but it's very tough to spot. But in Antarctica, it's easy to spot. Two of the most famous meteorites on the planet, especially two of the meteorite important for astrobiology. These are called Allen Hillis 84001 and Yamato 000593. Both are Martian meteorite, means these are rocks from the Mars, are detected from Antarctica. So that highlights it's a mecca, it's a heaven for meteorite hunters. So in summary of this talk, it's a product of the childlike curiosity, the Brian Parithian said, this discovery. And we really need to foster that kind of blue skies research without looking after the applications like astronomy and astrobiology. We should never forget it, you know. So that is the reason, like NASA, for example, American NASA or JAXA, the Japanese, or ESA, the European, they have strong wings on astronomy, but unfortunately that is completely missing in ISRO's system. We need to invest more money on basic sciences, you know. So, and yes, curiosity driven sciences is exactly that curiosity is how I made this discovery. And it provides clues on survival strategies of the extremophiles, especially the physiology and origin of life and astrobiology. All these are impacts of this finding. And exploratory research in general, and especially in Antarctica in particular, that is the only science continent we have, offers exciting avenues of the research, you know, including astronomical observations, meteorite hunting, and extremophile studies. So Antarctica plays a crucial role for all these studies. And we need to save Antarctica, the continent. The only way to save Antarctica is by adopting a lifestyle centered on sustainability, friends. And before leaving, I just want to share that another such finding that I made is Acetabularia jelakanyakae. And this discovery is from Andaman and Nicobar Island on a family trip. So I combined the curiosity. I'm always open to the ideas. Work and life all mixed up. So whenever I come across something unique, I take it. So I went to Andaman and Nicobar, the Port Blair area, with my sister's family and my mom. My sister supported my trip to Antarctica, you know. So the funder of the study is my sister in one sense. Yes, Antarctica, not Antarctica, you know, Andaman Nicobar Island is also is like Antarctica. It's a very special place. It's isolated, you know, almost 2,000 kilometers, you know, not 2,000, around 700 kilometers, right, from the mainland, isn't it? And I named it as a Jalakanyagae because it's something like a mermaid. You know, I love that book, Little Mermaid by Hans Christian Andersen. Jalakanyaga means, you know, the mermaid, isn't it? It is the Sanskrit epithet. And it's like an umbrella of a mermaid. So that's an imagination I had. So it looks like a beautiful umbrella. And of course, a mermaid can have that kind of fictional umbrella, right? So that is the reason why we named it as Acetabularia jelakanyakae. Again, it featured in BBC and other international media. And this talk is co-organized by Young Academy. I have written one of our important initiative, Mentex. We have two calls, spring and autumn call. Autumn call is now about to be released in this week. If you're a student, do apply for our call, and this enables you to work with our our fellows for 2 weeks, 2 months. It's a virtual internship with YAI fellows, Young Academy of India fellows. So it's completely free. So basically it's online internship, or mentoring. So you will find a mentor and you can work with a mentor. The mentor will help you with the career choices. They will help you to write a review paper, all those things you can do it. So do apply for the Mentex car, which is going to be released soon. Okay. So that is what the YAI Academy. So we also have the curiosity that I told you. It's a science show, a monthly science show. Every month I release this science show in this channel. So do subscribe to the channel. This is a channel where you're watching right now. So thanks for tuning in, and I'm open for some questions if you have. Thank you so much for inviting me for this talk.
Thank you, Dr. Felix. That was a very wonderful, lucid talk. We have some questions in the chat box. So one question is from Anuradha. She has said that how does moss survive in Antarctica?
Yeah, hi Anuradha. I have already told you that matter. There are multiple facts in it. One is that there is no soil, so it's getting the nitrogen and phosphorus from penguin poop, the excrement of the penguin. The so-called guano, right? So that is the reason that the moss can live in Antarctica. And second reason is that the moss in the active, it's a sporophyte. The gametophyte is extremely small, right? So the moss can live only during the summer months, not in the winter months. So in the winter month, in winter months becomes a dormant state, right? And it springs back to the life during the summer months. That is 6 months of the summer. Yeah.
Okay, there is another question. Just a moment. From Sanjay Sharma. So the question is that how we confirm that it's a new species of moss not observed anywhere in world.
Yeah, that is exactly how, any kind of plant discovery or animal species discovery. So you have to find first of all, you are confident of a genus level. You need to compare whatever has been described in that genus. For example, this is a bryum species. So whatever the bryum species in the world, we have to compare with all those described species. Morphologically, you have to compare. And also wherever the DNA sequence is available, you need to compare to find that your species is indeed new. So you need to show the synapomorphic character, that is unique physiological, morphological or physiological or even biochemical aspects of your species, which is not described yet. So that is the way that to report it as or describe it as a new species. Yeah.
There's another question from Venu Gopal. So he basically works on cancer research. Now, what he is asking is that, can you suggest about how to include cancer research in Antarctica project proposal?
Yeah, well, just my own thoughts. So Antarctica is an extreme habitat, right? So extreme habitat are formed for extremophiles, like this particular moss or archaebacteria and even eubacteria is more extreme than archaebacteria, though the microbiology students usually they have this kind of a misunderstanding that archaebacteria is a lot more ancient and a lot more labile, a lot more robust. Not really. These extremophiles can survive in extreme habitat because it has got its own unique rich tapestry of biochemicals, and that biochemicals might include anti-cancer compound, So that way you can emphasize on your Antarctic proposal, why that biochemicals are really important, and especially in Antarctica. Antarctica is also important because Antarctica has got the ozone hole, the largest ozone hole in the world. You know, it is now growing. It was the growth was actually the ozone hole was diminishing, but again now it started growing. And because of the ozone hole, UV light is now intensity is very high, and if you see any kind of bacteria or plants like this moss, it must be having anti-UV compounds in it. So anti-UV compounds matters for cancer prevention, especially skin cancer prevention. So why not? You can work on, you can develop a solid proposal on those grounds. Yeah.
Yeah, I have already shown, relating this anti-cancer research, I have already seen some papers on actinobacteria, which has been discovered from Antarctica, and they have some anti-cancer properties also. So the research is probably going on this aspects already from Antarctica microbiome. So I don't think there is any other questions. Just I want to ask you a few questions myself, that what about the salinity of this place? I mean, it's very close to ocean, so is the salinity very high over there?
You mean to say salinity of the ice?
No, the place where these mosses are growing. I just wanted to know that whether they're also tolerant to high saline concentration.
Yeah, no, it is the salinity is not there because it's basically Antarctica is a fresh water. You see, it's completely the ice in Antarctica is fresh water. You know, if you melt, you're going to get the fresh water, and of course, that is one of the way that the stations in Antarctica is making water. They're simply melting the ice, which is not that important. You know, I don't think it will have a more impact on the Antarctic ice melting. No, most of the ice melting is happening because of the global warming. So not in our stations though. You know, Indian stations, for example, Maitri is getting water from Priyadarshini Lake, while Bharati station is getting because of the from salt water reverse osmosis. So the moss is living in terrestrial locations, that is basically ice-free oasis, which is completely surrounded by ice. And no, salinity is not a factor there. Yeah, but of course, if you're looking at the seaweed, of course, we are also working on seaweeds from Antarctica. And yeah, seaweeds are, of course, it is in the sea, and it is naturally salt tolerant. Yes.
Okay. Another question I want to ask, just curiosity, that you have you ever studied the bacterial community that is present on the soil where this type of mosses thrive?
Not exactly moss, but we are actually, some of my students are working on epiphytic microbes on the on the seaweeds. So what are the microbes growing attached to the Antarctic seaweeds? We are working on it, and we are also working on ice algae, Chlamydomonas nivalis. We found Chlamydomonas nivalis from Antarctica. We've been working on Chlamydomonas nivalis characterization and describing that particular finding as well. Yeah.
Okay, thank you so much, Dr. Felix, for such a wonderful talk. I hope all of us is very much enriched by your talk. And before we end this session, I would like to thank a few people who has helped me for organizing this talk. And I would like to thank my principal, sir, Dr. Shyampur Bose, and our IQAC coordinator, Sri Rajesh Mukherjee, for their encouragement. And I am very much also thankful to Sri Mridul Ghosh, Head, Department of Computer Science, for extending his support. And I would like to thank all the IQAC members and GB member for their encouragement. I would like to thank my colleague, Shati Shet and Rituparna Roy Chaudhuri for helping me in organizing this webinar. And finally, I would like to thank all the participants for your cooperation. And regarding certificates, I would like to make an announcement that the link for your certificates will be sent to you by email within a few days. So please wait for your certificates. Finally, I would like to thank everyone present and who were patiently listening to us all along. So stay safe and goodbye. Have a nice day.